implementing access control, authentication, and account management, Module 5. First up, let's talk about some of the issues that we're going to see, such as access control and authentication services. One of the big ones is a directory service, and the big player there is LDAP, Lightweight Directory Access Protocol, port 389 for those of you that are playing the home version. Think Active Directory, think Microsoft, think I've got a domain controller, and I log on to my domain controller, and that grants me access to resources throughout the network. All your other vendors, your Apples and your Novells and some others, they've got their own versions of LDAP. Basically, each vendor has their own implementation. They're all more or less equivalent to what we're familiar with in the Active Directory world. So again, that's the primary protocol at play there. The concept being our LDAP server, then that would be our domain controller in an Active Directory environment, and our LDAP client, that would be you. And basically, you once you've logged in, then to access network resources, you're querying your domain for the location of that resource, and there's going to be access control restrictions and so on. Okay, there's a couple of directory management tools to be familiar with. There's a little something called LDAP-S, Secure LDAP, Secure Sockets Layer implementation of LDAP. Okay, and again, it's certificate based, uses public key infrastructure security. Some of the more common Active Directory, or not Active Directory, one of the more common directory services, obviously Active Directory. See there where it says Sun Java System Directory Server? Yeah, Oracle owns Sun now. So you're going to see potentially, I don't know if they're going to make a, A, I don't know if it's going to make it to the test anyway, but B, that hasn't been that recent. It's been over a year, so you should see references to Oracle System Directory Server, or whatever they call it in the Oracle world. Again, used to be something called Sun One Directory Server, but it's not called that anymore. There's also OpenDS, which is an open source version that runs on pretty much any system you want to run it on. Open LDAP, another one, and Open Directory is Apple's version. You don't see it much anymore, but some of us old school types recognize Novell as a major player, and there was the Novell. Well, first of all, there was NDS, Novell Directory Services. Before that, it was NetWare Directory Services, and then it became eDirectory, and I think it went through a couple of other names before people stopped caring about it, which is too bad. It was actually pretty good. I liked it. Of course, as you might imagine, directory services are kind of a central element to any organization that uses them, so you need to be aware of their vulnerabilities. Again, seeing as how it's a piece of software, there are potential denial of service attacks that can be run against your directory services, preventing users from being able to log on successfully, potentially. There's nothing within the directory service to prevent unencrypted transmission of data. You need to manage that. Again, the man-in-the-middle attacks, basically intercepting traffic between you and the directory server. Packet sniffing, capturing traffic, moving around. Again, anything that you want to keep secure, you need to have encrypted, even internally, potentially. Seeing as how it's software, and it's fairly complex, software, many lines of code, you might expect the occasional buffer overflow error to be exploited. And the big deal, it's at the bottom of the list, but it's still a big deal, is, let's see, is it the next slide or not? No. It mentions security of user and administrator accounts and passwords. I mean, we're all familiar with Active Directory. We've used it for years now. And it's pretty powerful stuff. I mean, it's a pretty neat little suite of activities, but it's only as powerful as its weakest link. I mean, if you're Active Directory environment can be compromised due to your weak password policies, that sort of defeats the purpose of having something that powerful in the room in the first place. So, take your account security seriously as well, because we don't want that to be the weak link in our directory environment. There's a reference in the book as well to backing up Active Directory and some stuff like what's all that stuff in there. But here's the deal: in a Microsoft system, there's something called system state. System state is a combination of files of various types that kind of individually are one thing, but only taken together do they accurately reflect the configuration of that device at a specific point in time, because these files, these processes are sort of interdependent on each other. You back them up as a unit, and then you restore them as a unit. You don't just get to pick and choose, like cherry pick just little specific things to back up, because without the corresponding other files that make up system state, you're not doing yourself any favors there. The thing to remember about Active Directory is the Active Directory database itself and the corresponding sysvol volume, which is basically a companion stuff having to do with scripts and group policy, actual objects, the group policy documentation sort of things. All those things are not objects within the object-oriented database that is Active Directory, but they're companion bits that kind of work in conjunction. Point is, the Active Directory database and the sysvol folder, those are all part of system state. So when you take a system state backup on your machine, those things are included in the backup. And when you need to recover Active Directory to a particular version, you do a system state restore of the system state at that time when you took that system state backup in the first place. There's a convenient checklist file on your website that covers this in greater detail, which is good. Okay, whoops. Let's talk remote access protocols. Okay, so again, users are in the building or they're not in the building. So for those users that are not in the building, there's a couple ways to get them in. Basically, you've got a remote access server connection. So you've typically, your different vendors all have their own version of a remote access server. That server that's on the periphery of the network somewhere, you connect to that, and then some activity on that server will determine whether or not your packet actually gets onto the internal network. And for your VPN crowd, the VPN access, you might have a VPN concentrator, whatever. But again, you're remotely accessing the system either through a dial-up sort of connection or a VPN connection. In the text, we're talking about, here's a concept known as tunneling. We've talked about tunneling before. And what a tunnel is, it's basically when you encapsulate one protocol inside another. It seems all very complicated, but it really works like this. If I'm encrypting my data, and not only encrypting my data, encrypting my headers like I would do in a VPN, well, then your internet routers can no longer read the IP header, so that packets, you can't route that thing. So essentially what you do is you have your original packet, you apply the encryption, for example, you configure it following your IP security standards, your IPsec standards. So now you've got an encrypted packet, but it's no longer routable on the internet. So what you do then is, to make it routable, you take an unencrypted IP header. Basically, we're calling this the carrier protocol. We're just tacking an unencrypted IP header on this encrypted packet. That's going to get it across the internet, and then at the other end, we pop off that carrier protocol, and then we perform whatever magic we need to perform to decrypt our IPsec packet, and then we're left with the original packet. So you have your original packet. That packet is modified in some way with IPsec or PPTP or whatever you're using to modify that. And then we're taking that modified packet, sticking an unencrypted IP header on there to get it across the internet, and then eventually we're left with the original packet at the other end. So that process is known as tunneling, where essentially you're creating a connection in one protocol to carry the data and information from another protocol. All right, so don't worry too much about the mechanics of actual tunnels themselves. This really doesn't. It's not really what that means. Okay, so remote access protocols. The first one at the top there is PPP, point-to-point protocol. It's been around for a while. It's a legacy standard. It's pretty much the industry standard layer 2 protocol for carrying network layer traffic across networks. So again, PPP, industry standard, everybody uses it. And there's a couple of versions. There's a PPP OE for specifically applying it to Ethernet networks. There's a PPP OA for applying it to ATM networks. And ATM in this context stands for asynchronous transfer mode, not automated teller machine. Okay, so PPP, it's industry standard way to move traffic around at layer 2. Now, our VPN protocols are listed next. And again, this is a representative sampling of those guys. An older Microsoft protocol, PPTP, point-to-point tunneling protocol, is based on PPP, has its own its own encryption mechanism. PPTP uses something called Microsoft Point-to-Point Encryption, or MPPE, to do the encryption. Has its own onboard encryption mechanism. PPTP is IP only. That's the only protocol suite it supports. And basically, it's older. It's not as secure as some of the newer protocols. In fact, even though it's a Microsoft protocol, Microsoft says, hey, look, unless you really need to use this, and the reason you might need to use it is because maybe you still got some like really old clients, like Windows 98 clients or Windows NT clients on your network. Nobody does anymore, so there's no real good reason to use PPTP anymore. So that takes us to a protocol known as L2TP, Layer 2 Tunneling Protocol, which is kind of a combination of the good stuff from PPTP and something called Layer 2 forwarding from Cisco. And those things have been combined into this kind of tunneling protocol. And L2TP actually is the tunneling protocol. It is able to tunnel a variety of network formats, TCP/IP or ATM or frame relay. There's others, Apple Talk. There's others. Mostly, though, we see this in an IP environment. And L2TP does not provide its own security, so it uses IPsec to provide the security. And it uses IPsec in what's known as transport mode. So the deal is, we've got IPsec comes in two modes. There's a transport mode and a tunnel mode. In transport mode, IPsec encrypts the payload, and we use the and that's great. Let's see, according to our text here, L2TP doesn't provide encryption. It uses IP security, transport mode for authentication, integrity, and confidentiality. Yeah, that's not true. Well, that is true, because transport mode encrypts the payload. Now, to encrypt the headers and stuff, IPsec also has what's called a tunnel mode, which encrypts the payload and the headers. But the L2TP basically uses the IPsec just to provide the encryption, so it uses transport mode encryption. Little side note there. IPsec in tunnel mode is a perfectly valid VPN solution. However, IPsec does not scale to large enterprise networks as well as L2TP does. So L2TP is still the preferred tunneling solution at the enterprise level, and we use IPsec to provide the encryption in that case. Then this last option, secure sockets tunneling protocol. First of all, these other protocols require additional ports to be open on firewalls, which is great unless you get someplace where those ports aren't open and you might be unable to create your VPN connection, and that's bad. Well, everybody supports SSL, and you're doing secure web traffic, that's port 443. Well, SSTP is effectively, think of it as a browser-based VPN. It uses the same port that HTTPS does, uses port 443. And everybody supports port 443, so SSTP is simply leveraging kind of existing encryption technologies and just kind of extending that to a VPN. So you might see some reference to SS, Secure Sockets Tunneling Protocol. Very clever. No additional ports need to be open on the firewall. Should be good. All right. Here's a weird concept for you. Something called HOTP. We already talked about HMAC, hashing message authentication code. This is basically an HMAC one-time password, an OTP. One-time password is based on the kind of wartime concept that, hey, I've got some secure data. I'm going to create a password that's going to be used one time and one time only. After it's used, it's not reused. So it's that's kind of really your answer to kind of the perfect encryption is an encryption method that is only used one time and then not reused. So HOTP is an HMAC-based one-time password based on an algorithm that generates one-time passwords using an HMAC code to ensure authenticity of the message. So the user that receives the encrypted message that's encrypted using the one-time password, in addition, there's an HMAC code that's essentially tacked on to the message, and essentially as that message is decrypted, the appropriate block that is generated during the decryption process is compared against the HMAC code, and those should match. Those should be the same, indicating that the message hasn't been compromised in transit anywhere. So it's kind of a good combination of secure technologies there. So just in case you see that, most of our major mobile operating systems kind of support that to some degree or another. So again, HOTP, HMAC-based one-time passwords. There's also a timed version of that, which has a limited life expectancy. In other words, once this timed one-time password has to be decrypted within its survival window, and once that thing is no longer active, then you're done. That message is no longer going to be decryptable. So same thing, it's a timed HMAC-based one-time password. And I just saw a reference fly across the screen about using your RSA secure ID token to access the Go system. Yeah, that's a time deal as well. That you've got that little fob, your little key fob deal, and it's got a number on it, and that number is going to change within some fairly short period of time. So if you need to decrypt that or gain access to that system, when it asks you for that value, it's synchronized. It's generating the same value on the same clock cycle as your device is. So so it knows if that device is properly synced up with the same setting on the server, which essentially is going to be how that authentication is performed. So again, that's very similar conceptually to this. Okay, now PPP, point-to-point protocol, has a couple of different authentication methods that it uses. One of them is known as password authentication protocol. We don't like it. We don't use it. To remember it, it's use this mnemonic aid. PAP is crap, and here's why. Our client and our server, we configure both of them with the username that's going to be accessing our system, along with the password. So the server's got the credentials, the user's got the credentials. So when the user shows up and says, "Here I am, and here's the password." Sends it in plain text across the wire, and the server goes, "Yep, that's the password. Come on in." And you might say, "Well, that's not necessarily the internet. That might be a point-to-point deal." But you know what? That's just generally not good. It's generally considered a legacy protocol. There are other better protocols out there. Speaking of, there's the other PPP authentication protocol known as CHAP, or Challenge Handshake Authentication Protocol. So here's how this works. Same setup. You configure the username and the password on both of the, both sides of the link there. So now when the remote client wants to connect, the remote client says, "I want to connect." And the remote access server says, "I issue you this challenge. Mary had a little lamb." So sends Mary had a little lamb over there. So now on both sides, both of these guys are going to run Mary had a little lamb and the password. They're going to input that into their hashing algorithm, MD5, whatever they're using. That generates a hash. That becomes the response. So the client sends that hashed response, with the password in there, across the network. Now you can't extract anything useful out of a hash. It's just the way they are. So it's completely safe going across a public network. But when it gets to the remote access server, that guy has already calculated his hash. He compares it to your hash. They should be the same, because if they're the same, that means, hey, that guy used the correct password to create this hash, and that's all I need to know. I don't need to see the password. I just need to know he used the correct password. So that's good. So the good news is the password does not ever travel across the link. It's much safer, and it accomplishes what you need to accomplish. And there's multiple versions of CHAP. One of the ones you'll see on various exams, you'll see a version called MS, as in Microsoft CHAP v2. And Microsoft CHAP v2, the claim to fame of that particular version of CHAP is that it supports mutual authentication, meaning both sides authenticate. In this case, only the remote client is authenticating, but with like MS CHAP v2, both of these guys would authenticate to each other. So that's and there's other things, but that's the primary benefit of that. Okay, so for remote access, for security purposes, we want to use VPNs whenever they're indicated. If you can use a VPN as opposed to not using the VPN, use the VPN. And of course use secure tunneling protocols, such as that we know them as VPN protocols, like PPTP. Better still would be L2TP. Potentially even better would be SSTP. That one-time password authentication deal, that's comes in a couple of versions. The normal version, the HMAC based version, or the timed HMAC based version. And avoid using PPTP or PAP is what they're saying. Password authentication protocol is for losers. PPTP is for losers. Stop using them. Use something newer and better and less likely to be compromised. All right. That's the end of that topic. Let's move on to the next topic for a few minutes. Actually, we're still in the same topic here. Here's an encryption mechanism known as PGP. Stands for Pretty Good Privacy. Says it's publicly available. It's not really. It used to be. PGP essentially was acquired by McAfee some years ago, and there's a open source version of that available called GPG. But the point is, again, it's used for email security. It's an alternative method. We normally use SMIME, Secure Multipurpose Internet Mail Extensions. Outlook uses it, and all the Microsoft clients and so on. But PGP is an alternative. It's an alternative public key infrastructure-based process. Okay, so you just kind of be aware when you see PGP, go, that's an email security protocol, which is exactly right. We talked about Radius already, remote authentication dial-in user service. On the right of our diagram here, we've got our Radius server. Now, the reality is that in an Active Directory environment, that Radius server is actually running on your domain controller, which is convenient because that's where the user account database is anyway. But so we got a Radius server, and on the far left-hand side of our screen there, we see the clients. Now, in the middle of our screen there, we've got our remote access servers. And the remote access servers, we've got them configured as Radius clients. So they have to understand Radius, and they're actually clients of the Radius server. You're not. You're just a remote guy. You're just connecting to a remote access server. But the remote access server, he's the guy communicating directly with the Radius server. The Radius server replies to the remote access server, and the remote access server basically sends a proxied reply to you, indicating that, hey, you're eligible to pursue life, liberty, and the pursuit of happiness there. Come on in and surf away. Have fun. Notice, if you will, that we've got a single Radius server in this diagram, but it's certainly possible to have a cluster, or the reality is, in a Microsoft Active Directory environment, you've got multiple domain controllers, so you've got redundancy built into the system there. Okay, so again, these remote access servers, those are our remote access servers that serve as termination points for those dial-in connections or those VPN connections. Now, Radius is just one of several remote access protocols, remote access authentication protocols. There's Radius. There's a similar protocol known as TACACS, Terminal Access Controller Access Control Services. There are various versions. TACACS Plus specifically is the one that's used by Cisco, and it's again it's very similar to Radius, but it's different in certain key ways. Provides multi-factor authentication. Radius doesn't really do that. Encrypts the entire authentication process. Radius doesn't really do that. It's TCP based. Radius is UDP based. Sorry, Radius is UDP based. And again, it's there have been several versions of TACACS, as you can see, over the years. But again, the thing to remember is TACACS, in some form, is a remote access protocol. It used to be, you used to know that TACACS used port 49, although that does not seem to be testable these days. And before I leave, there's one more. There's a protocol known as Diameter, and Diameter is an extension of Radius. In fact, in the Radius, well, actually, there's a brief description of Diameter in the thing here. So Diameter is like Radius, but it's if you're a math geek, it's twice as good as Radius. Get the joke? Diameter, Radius, get it? Twice as good. Okay, fine, whatever. Anyway, so there's three: Diameter, Radius, and TACACS are the three remote, the centralized authentication services that you're going to see a reference to probably on the test. There's a reference to Kerberos. Now, Kerberos, you recognize that, of course, as the authentication method we use in Active Directory, and Kerberos was, originally stolen from the Unix environment. So technically, there's a little interoperability that can happen there, but it's what's known as a ticket granting ticket. So you authenticate to Kerberos, and if you're successful, if it likes your password, it issues you what's called a TGT, a ticket granting ticket. And what the benefit of that is, that's the second bullet, that SSO, that single sign-on. So you log on to your Kerberos-based system, right? Active Directory. Then, as long as you stay logged on, you can go wander around accessing resources and stuff. Well, what happens is when you show up at the resource takes a peek at your Kerberos ticket, verifies that you've got a good Kerberos ticket. It's valid, it hasn't expired, blah, blah, blah. And then it goes, okay, that's good enough for me. You know, you don't need to show me your credentials again. This proves you've already showed them to somebody. So now I'm going to issue you an access ticket so you can go access the resource. So again, Kerberos allows you to access resources throughout Active Directory, you know, multiple domains, you know, within the Active Directory forest, you know, because, you know, Kerberos from one, you know, domain can communicate with Kerberos in the other domain and verify that your logon in that other domain was valid, and that carries some weight in these other domains. So again, it's an old Unix process, and it's used for authentication, and it supports SSO, single sign-on. And again, the benefit there is you log on one time and have access to multiple systems during that time frame. Here's one you probably haven't seen: security assertion markup language. You're familiar probably with HTML, you know, for web pages. XML, pretty much the de facto standard for exchanging text-based information across different systems. Well, this SAML is based on XML and is for exchanging authentication information. And that's probably, again, you can read there's a very small blurb in there, but again, it's a sort of a universal standard that lets you exchange specifically authentication information across, you know, different systems.